Part 1 of Competency 3 quiz. In this video, we will work with operations and number theories. Number 1. A traveler in Europe noticed that on a certain day that 3.85 euros was worth 5 US dollars. Based on that rate of exchange, 10 euros is approximately equal to how many US dollars? Okay, this is actually proportion. Okay, you may not remember this. However, what we need to set up is euros to dollars. We're given 3.85 euros to $5. Okay, so then we know that we want to talk about, well, what would 10 be worth? Or rather, approximately how much would the US dollars be worth if we had 10 euros? Okay, so this is just a proportion. If you remember, you cross multiply. Okay, first we would set up going this way. All right, so that means we'd have 3.85x is equal to. Now, the other way, which is 10 times the 5. Now, we have an algebraic situation, so divide by the coefficient on both sides. And that means we divide by 3.85 on both sides. And now we have something valid to put into our calculator. Okay. And it's going to be an approximation, right? And we can tell that from our ABCD options. Okay. And it will also be a dollar amount. Okay. So let's see what we get here. Let's set up our fraction and say 10 times the 5 and then 3.85. Now, you may have noticed that I didn't do any of the multiplication in my head. And if you've watched other videos with me during a test, probably not the wisest thing. You get tired. And we round that, and that gives us option D. Okay? All right, let's go to number 2. Which one of the following is an irrational number? For this, yeah, you should know the rules. It'll make things faster, but you could put them in the calculator. But even if you did, you still would have to know what the rules are. Irrational means that the number, when you put it in the calculator, the decimal goes on forever. Okay. Well, I know by looking that D doesn't. The minute it says repeating, it does go on forever, but repeating is still considered rational because we do have we can make an exact value. Okay, 1A, I know that that is terminating. It doesn't go on forever, but you can put it in your calculator if you don't know what that is. So 1 divided by 8, remember to push your toggle. Well, it does stop at 5, so that's not irrational, okay? A, I already know that too because I know that you can get a cubic value out of 64, but doesn't matter. Put that in your calculator. Now, there is a little, I don't know, quirkiness about this particular family of calculators. You have to put in the 3 first, okay, to make it like work. And I'll show you what I mean. Okay, if I put 3 second and you need this one above the caret up, okay, put in your 64 and then push enter and it's 4. So we'll get rid of, I mean, that it says which is irrational. Well, that's rational, so it goes away. So we're looking for B. Okay, but before I show you B, let's do it the A the other way. Okay, so let's go second and caret up. See what it does? It says put in the answer. It wants you to use 4 as your, for your radical, instead of cubic, it want quadric. Okay, so no, that's not going to work. So let's clear that out. It's just a quirkiness. You have to type in whatever that root is. You type in the root. The way we did it a second ago, it was asking for the fourth root. And we are like, okay, no. Okay. Doesn't matter. Let's figure this or prove rather option B. So we need second. We're going to use the normal square root, put 20 under it, push enter. Well, you have to push the toggle to get the decimal. And I can tell you right now, that's not terminating. That's repeating forever. Okay. All right. Let's see. Number 3. All right. What is the sum of the multiplicative inverse and the additive inverse of 5? Okay, we know that every whole number is over the imaginary 1. Now, if we want to take the multiplicative inverse, we need to use a reciprocal. You have to take that thing and flip it upside down. Then we're going to add it to the additive inverse. Well, if we have positive 5, the inverse is minus 5. Okay. Now let's go back to this multiplicative inverse. Remember, you know that you have the right thing if when you multiply them together, you get 1. Okay. That's how we know. Okay. So what do we need to do? We actually need to say 1 over 5 minus 5. And I can tell you now that's a negative number and it isn't equal to 1. So that really eliminates B, C, and D. They're gone. And I say it's A. Well, let's pop in the calculator and verify that. Okay. All right. So we have fraction and we need 1, go down, 5, arrow over. And oops, not negative. We want minus 5 because it's saying to add them together. Well, if that kind of throws you off, you could say, let's go back. You could say plus, then in parentheses, say negative 5, which is basically how I had it written in the first place. And that's what the sentence says. So let's push enter. Oops, if you push it all the way. Well, yeah, we have to push the toggle, and there you go. It is option A. All right, let's try number 4. Number 4. For any two real numbers, x and y, which one of the following is not necessarily true? Okay, well, the first very basic law of absolute value is that whatever's inside the absolute value, it doesn't matter, it comes out positive. So A is definitely true because when we pull those out, it's just going to equal x. So that is true because remember, it says not necessarily. Okay. Well, let's look at B. Well, let's say that x is negative. Okay. Well, that would equal, okay, x over y. However, what if we went in the other direction and we had negative x? And we said negative x over y, and then we went backwards. Can we say the reverse? Because that is number theory. If they're equal to each other, it has to be true either way, which would be reflexive. So if we have negative x over y, is that equal to the absolute value of negative x over y? And that's not true. I would not say that this is necessarily true, but we could try that with some numbers. Well, if you think about it, it's just not going to happen, okay? Negative x over y is not equal to the absolute value of y, okay? And let's look now, if we did this, if they rewrote that, and we'll look at the other ones too, I just had a thought. Think of it like this. If we said x over y equals, right? And then we had negative x over y. Those are necessarily true. okay? Or we did this. We said the absolute value of x over the absolute value of y. I would agree with all those, but I'm not going to necessarily agree with B. Okay, now C. If we have x times y, whatever that is, we pull it out, would it equal absolute value of x times x absolute value of y? Well, yes, you could use numeric values and put them in and prove that to yourself. Okay, let's say that x equals 2, let's say -2, and y equals 3. So, oh, no. Oh, yeah, that'll work. Never mind. Sorry. Okay, so we can use the positive, negative of every one of those. I looked up at A for a second and I thought, okay, wait a minute, they have to be this positive, negative. No, that's not true. We're looking at C. So remember, whatever value we get, we don't have an absolute value option on our calculator. So we just have to remember the rule. So if we said -2 times 3, that's -6. But if we had that in the absolute value and pulled it out, it would just equal 6, okay? All right, whatever we get, we have to just apply the rule after the fact. So now well, either way, if we said absolute value of -2, the absolute value of -2, that just equals 2. And the absolute value of 3 just equals 3. So that would just be 2 times 3. Well, that's just 6. Well, that's the same thing. Okay, remember, you have to apply it on your own, right? Okay, because the absolute value of -6 equals 6. Okay, so yes, we're okay. Now let's look at adding and subtracting. Okay, now this we can do something with here. And remember, whatever value we get, we have to apply that absolute value after. Okay, so x -2 minus 3, okay, that's in the absolute value. Oops, watch my handwriting there. Okay, all right. Well, I said I was doing better. I guess I was trying to correct it. That didn't do much good. Okay, there. Okay, so now we have 3 minus 2. Okay, if we pull the left-hand side out, we have -5. And -5, the absolute value of -5 is simply 5. And then if you can't muster these rules, just put in -2 minus 3. So that's going to be -5. Pull it out of the absolute value. Remember, if we end up with -5, just turn it into a positive. Now let's look at the other side, okay? I have 3 minus parentheses -2. Well, that's 5, okay? Remember, we're applying the absolute value, okay? Which this actually becomes like A, all right? So that is true. So C and D are true, and the only one that's a little wishy-washy would be B, okay? All right, now let's look at 5. Which of the following is best represented by the root of b with a squared under the radical? Okay. All right. It's a b root, not a square root. So if you remember the rules, okay, the a and the b become a fraction on their own. Okay, and we only have one of those. It doesn't become a division with a and b, and x is the base. So this is incorrect. So when you look at these, always tell yourself this b becomes the denominator and this a becomes the numerator. Whatever is under the radical, the exponent under the radical becomes your numerator. Okay, so that's option B, and C and D are obviously out. Now, when you go to take the test, if that bothers you, put a value on it. Call A 1 and call B 2. And you could call X, you could say X is equal to 3. Put values on that and see what happens. So if we put the values on it, then we want to test out 2, which is the square root of, oh, it's not X. X is 3, which would be 3 to the 1. Well, that's just 3, but it doesn't matter. Then we could try that on each one of these and see if it works. Well, we could try that here on B, and we could say 3 to the 1/2. And we put them both in and see if it works. All right, let's try that. 3, carrot up fraction, 1, arrow down to 2. There's your decimal. Now let's try the square root. Now that 2 is a square root, so we have a function button for that. It's when you have 3, 4, 5, other roots, higher roots above 2, greater than 2, then you have to use this other, the carrot up, second carrot up. But we don't have to do that. Okay, so let's do that. We have, or I could show you both ways. It doesn't matter. We could have second. Okay, there's our square root. And then 3. You could even say carrot up to the 1 if you want. Enter, toggle, same number. Well, let's try it with that other root. Okay, remember you have to put the 2 in first, then second, carrot up. Now 3, carrot up to the first, which is what we have over here as a trial. And there you go. It's all the same value. Okay, so that kind of verified option B in our mind. All right, let's look at number 6. Which expression is not equivalent to 4, which would be times, because you have in parentheses, 4 times in parentheses, the absolute value of 2 minus 5. Well, let's go ahead and put that in. Let's think about that differently. Well, I'm looking at one thing. I'm looking at A. We could go ahead and do this, but we can't just say parentheses where the absolute value is. And that is because this is actually equivalent to this. Okay. And when you pull it out, you have 4 in parentheses 3. Remember, anything inside the square root, if it ends up being negative, you pull it out as a positive. So the answer is 12. Okay. So looking at this, it says not equivalent. And that's kind of what I was looking at. Well, A, if you follow through, that looks kind of like what I have there. Because you would have negative 3 times 4, that's negative 12. But that's still inside the square, the absolute value. Sorry, the absolute value. You pull that out, it's going to be positive 12. So I disagree with that one. And we can't just pop it in the calculator because we have to deal with the absolute value. Now, we could pop everything inside the calculator, like B. So let's just put all that in and see what we get. So 4, actually, let's arrow over parentheses, 4, close parentheses, 2 minus parentheses 4, close parentheses 5, enter, and that's a negative, but it's inside the absolute value. Pull it out, it becomes positive. Well, they're asking for what's not equivalent, so that one can't be it. What about C? Well, if we take inside the absolute value, that's negative 3, and it says multiplying. Well, that's what I have over here, right here. So that's the same thing. So we're left with D because we want what isn't equivalent. So let's cross our fingers, put it in the calculator, and let's hope it's correct, okay? Well, I can tell you it isn't gonna be equivalent, and I'll tell you why. Right here, that negative is not inside the absolute value. So it has to be negative in the end, okay? And because of that, also, you put it with the fact that inside each absolute value, those items, they're already positive. And because of that issue, we can just put everything in parentheses or not even type the absolute value because we already know it's positive. So let me type that out without the absolute value. Well, look, that's what we have up here. Okay. Or I could replace, do double that the parentheses, but it's what we already have in the calculator, and that's negative, and it's not inside of an absolute value. Now, it would be different if there was an absolute value around everything, like right here on B. Okay. That's not the case. Okay. It's having the negative without an absolute value applied to it makes this the correct option. All right. So we're going to select D. D is correct. Okay. This is last question in this particular video. I'm going to watch you. I'm sorry. I want to thank you for watching and subscribing and liking. You guys that are subscribing, you're the best. You are the best. And don't forget to share us with someone. They may subscribe too. We love the support. Happy testing.